Hi, welcome back. I hope you really took a break because the last part was filled with new content for you most likely, so it was worth taking a break to digest everything. This part, we're going to write the services or service methods that we need in order to fill these combo boxes here with content. First of all, we needed a list of the years that are stored in the database, and then we need a list of the symbols. And at the end of the last part, we had a look at the SQL statements that we needed in the database. And now we're going to write the web service methods that we need in order to provide that information to any web application or also to any desktop application that wants to use our web service. So in a nutshell, in this episode or in this part, you will learn how you can create services and service methods in XData that connect to a database, get a connection, and then return the result of a SQL statement. The repetition in our program so far, we have the main form that allows us to start and stop the server with the developer UI. And we implemented the server container with the XData server that is hosted on port 80 on this computer that we started on. We also looked at the dispatcher that we can set its active property to true and false in order to start and stop the server. And then the database manager is providing us access to the SQLite database using FireDAC in a multi-threaded environment. And the key here is multi-threaded environment that puts certain requirements on the database connection, and all of these have been implemented in the last part of this series. So now we can actually use this database manager that we implemented to get a connection to the database, execute a SQL statement, and then return the information. But before we can do that, we actually need a service, because right now, if we start our XData server, there's nothing going on. We start it, and then we go to localhost port 80, copy paste right here, start the browser, paste localhost port 80, nothing is being shown. And if we go to Swagger UI on localhost, it says even that there is no operations defined in the specification. Okay, so let's remedy that. First of all, we can use a wizard again. The documentation from XData gives you an alternative, just writing code. I still prefer using the wizard. So file, new, other, TMS XData. And instead of the server, we now want to add a service to an existing project. Make sure that the project with the XData service or the XData server is selected in the project manager, and that you're not having, like, if at some point you will have your web application in the same project group, make sure that the current XData server is selected. Okay, and then you can name your service. I'm simply going to enter stock, and don't add service because the service is added by the template. We don't want to add any sample methods, but we want to generate interface and implementation in separated units. It already hints at the fact that XData services are interfaces that you have to implement. So these interfaces are then registered to the XData server, and that's the way how XData works internally, that these interfaces register as a service, and thus you can extend your XData service with as many services that you want by just adding classes or interfaces to your executable or project. So now here we get the stock service implementation, very long. So I immediately save it, go to source, and then I create yet another directory inside of the service source, which I call services. And in services, I add a U or unit, and then I shorten implementation to impl. And then the same for the stock service, go to source, services, add a U in the beginning. And of course, for the implementation, we have to update the unit name here with the U. And then anything that you define in the interface, you have to implement inside of the implementation file. So looking at the uStock service here, we want to do two things, right? We want to get the years and we want to get the symbols. So what we can do, we can simply write function symbols And what do you want to return? Well, we want to return a list of symbols. I'm going to show the way how we can use data transfer objects here. So TDTO, data transfer object, symbols, which is going to be a list of some sort. And then function years, same thing, TDTO years. But there I'm going to do something else. So you're going to get two different ways of returning things easily. And as I just said, we have to copy that into the implementation to actually implement these things. Control-Shift-C. And at this point, you're good. You have them implemented. Of course, we need to implement these types. So we add yet another unit to our project, add new unit. And this is going to be source services. This is going to be u stock service dot types. I usually do. Type, we need TDTO symbol, which is a class. And then we defined TDTO years. And years is easy. I'm simply going to do TList of integer. And with sorry, I mistyped TDTO. I could have also done TDTO symbols equals TList of string, because that's all we need really. But I want to show you how you can use actual classes. So I'm going to say TDTO symbol. And in order to do this, we need to use system generics. If Delphi helps me, system generic. No, Delphi doesn't want to help me, so I'm going to close the project again. This is the problem with Delphi 12. LSP is not really cooperating. So we open the project again, go to source, services, use stock service. And I show this to you that I struggle just as anybody else with the new LSP additions. So if we do it now, there we go. It works again. Sometimes it's enough to simply click here, tools, reload LSP server. But without code completion, it's really, really tough to use. And then here, we're going to define the symbol. And the symbol is really nothing but a name if we think about it, right? So what we do is public, prop F, tab, name, string, and that's it. The IDE does the rest for us. So that would be a data transfer object defined as a class. And then we have a list, which only contains DTO symbols. And then the years are just a list of integers. And at this point, if we use this both here, u stock service types, and then we use the same in the implementation. That's the only thing you have to remember. It's not just the interface. You always have to do these things on both sides now. So this can go away, this, and then here. Let me reformat that real quick. Okay, and with that, we have all the types in there. And if we compile this now, this works. Of course, we need to define the result, and that's actually what the compiler tells us, that both methods are undefined or might be undefined. So just to get into the jive of things here, I'm simply going to say result is TList, not TList, TDTO years dot create, and then result dot add 2024 and result dot add 2023. Just so you see how easy it is to define these things. In the implementation, of course, if I start the server now, don't touch the symbols, of course, because that's undefined. But now, if we go into our Swagger UI, we see that the stock service is defined because we said we want to call it stock service. And we have two service methods right here, symbols and years. And years also is, we have a preceding post. That means all of them are post requests. The HTTP protocol has certain verbs, and one of them is get. The get one is the one we use every single day when we enter an address here into the address bar in the browser. That's a GET request. A POST request is usually if you have a contact form and send something to the server. That's when we use POST, but it's not really that you can only use it this way. You can use a POST request, as you see here, in order to get information just fine. So we click try it out, click execute, and there you go, 2024, 2023. That's exactly what we added. And of course, and this is the power of XData, you didn't have to write any of the JSON stuff. The serialization, as it's called formally, to JSON is done automatically by XData. So we don't have to do anything manually. It's done for us. So the JSON document that's returned actually contains an object, a single object, with the value property. That is something that XData still inserts. You can't get rid of it, sadly, maybe in a future version. But then you get an array, and the array, of course, is the list of integers, 1, 2 integers. That's the result. And why is this result being generated? Well, because we added those, hard-coded them, so to speak. And this is where our database comes in. Now we want to use the database to return a list of those items. Looking at Swagger UI again, though, if we take this, and this is something that is very, very important to understand, this is the URL. This is what we call the endpoint. And if I copy paste this and paste this in here, we see HTTP localhost document. This is how you can address this endpoint. But the problem is if I enter, I get an HTTP error 405 because it's a POST request. But believe it or not, you can change that. So you can stop the server, you go into the service, and then we can make this an HTTP GET using custom attributes. HTTP GET. These, of course, come from XData. If you read the documentation, you can decorate your service method with certain custom attributes. HTTP GET, HTTP POST, HTTP delete. All the different verbs that are available in the HTTP protocol are available. And now, if we recompile the project, we should see that the Swagger UI documentation changes. So if I go to this link again, we see that it now flipped over to GET. And now I can use this link that I just used, and boom, and I get a GET request, and I can execute it in the browser as if it were any other web address, because it's a GET request, right? And here is a chart of how the data is being organized. This is a browser plugin that I use. So looking at JSON information is actually not that difficult if you have the right browser tools installed on your system. So going ahead here, so flipping this to GET allows us to test it even just like in a normal web browser, so to speak, the result. And of course, F12, the developer console, is more than helpful if you need anything like this. For example, if you press enter here, we see that here is the request to the years, and here is the response. I can see the headers in detail, what is going on. So all that is included in your browser. You no longer need tools that you have license codes for. Most of the stuff can be done in the browser. And of course, when you have a post request here, you can use Swagger to try it out. Right now, we don't have any parameters, but you will see as soon as you have parameters, you can still use Swagger, because then you get an input form where you can toggle the parameters or enter values for the parameters. It's really, really comfortable. So with this, we have the services defined, but now we need to fill them with life. And I usually do not implement anything in this unit right here, because this should be just focused on the implementation of these two methods. So I call some sort of controller class, manager class, and the same for here. Like, this stays as slim as it can be. Obviously, there's implications why XData has an interface and an implementation, because the interface, if you want to use XData in other Delphi applications, you can link the interface. You would give the interface to other developers that want to write Delphi applications for your XData web services, and they can use XData themselves to retrieve information from your web services without, and this is the key point, without seeing the implementation. So you're just giving them the interface files, but not the implementation files. And that's the reasoning behind it. However, here it is just for code organization that everything is easy to maintain. Okay, in the implementation, we leave it as is. I'm just going to create another class, add new unit. I'm going to call that class in the source directory in services, stock service controller. That's what I'm going to call it. And this class type stock service controller as a class. And yet again, we have, you might imagine, for each and every single method that we have in the service, we're now going to provide the implementation. So here we're going to have function years. And again, same result types, tdto years. And here function symbols, tdto symbols. Okay, and of course we need some units as part of this controller. Let me copy paste them from the source code. Of course, we need the types, we need JSON, and we need sysutils. JSON will come into play for later endpoints that we will add. These two are also basically done with the types that we defined in the types unit. So Control-Shift-C, and we have those implemented. And inside of the implementation, of course, we also need to use some units. First of all, we need to use our database manager, right? So database manager, because we need that to get the connection and all these kind of things. Then we need generics. Nothing works without generics. Generics.collections. Delphi is being difficult again because we added this file to the project. So the easiest thing is you reload the LSP server so that it realizes that there's a new file. And then we also need, from XData, we need sys exceptions, because instead of having certain return values of your web services when a certain error occurs or something is not found, you can use the HTTP protocol to signify that. The most common HTTP status code is 404. Whenever you enter a web address that is known, it says 404 not found. And that's exactly what you do. Let's say you don't have any symbols and you don't have any years in the database, your list is empty, you throw a 404 exception, and XData will do the rest for you, that your web service actually returns 404. I'll show that in a second. So with that, we go into the years first, because that's the one that we had hard-coded before. So it's pretty easy because we looked at the SQL statement before, so we don't have to think about it that much. So what we do is we say result is tdto years.create. That creates the list. And this is very important to know. Like, the result that you return never has to be freed, because it wouldn't make any sense, right? If you create something that you want to return and then you free it before your own method ends, that doesn't make any sense. So this will be freed by XData automatically. Okay, so you don't have to free that manually. Then you have to get a query, and this query, of course, comes from the database manager. Database manager, and now you see how comfortable that is. Shared dot, and what do you want? Well, you want a new query, so you call get query, done. That easily you get your query. So you say try finally L query, and now the most important thing, you don't call lquery.free, because then you would not return the connection back to the pool, right? Instead, you say tdatabase manager.shared.release query from lquery. Okay, so you put the connection back into the pool and release the query from memory. And then, just like any other database application, you write your SQL statement. I always say, with the new technology in Delphi 12, write them like this. Makes it very much readable. And I copy paste them from the source code, like so. There we go. We have our select distinct, update year from stocks order by year descending. That's the statement that we had. And then we can open our query. And now if we do not have any records, so we say if lquery.eof, then begin. That means this doesn't return any records. That means something is obviously wrong. Then we raise an XData HTTP exception. That's a type that's defined in XData. 404 is the status code. And we say no years found. That's it. That will exit this method. So here you can continue writing without adding an else or anything like that. And what we do here is we iterate the database. So we say lquery EOF, and of course not. So while it's not EOF, begin. I always read this first, lquery.next, because you wouldn't believe how many endless loops or infinite loops I created. Then you say result, which is our list.add. And we have to add an integer, right? And the integer is, well, lquery field by name. What's the field name? Up here, year, as integer. And that's it. So that way we get all the years out of the database. Then you can, if you want, you can go lquery.close. You don't need to, but it's gonna get freed right here. So it's gonna get closed anyways. It's not necessary to do that. Okay, so with that, you have a good, robust implementation. There's one thing that can be done better, because let's say anywhere in this code there is an exception being thrown, that would mean that this result has been created, but XData only frees this on successful execution. So what you can do is you can try wrap this and then do not a finally, but an except. So catch everything, result free to make sure that and re-raise the exception that was thrown. So that way, if you create this result, you make sure that this result is definitely freed, even though if there is an error anywhere in this code, because XData only frees it if the result is returned successfully. Okay, so with that, we have really, really robust code. We start the XData server, start, and then we go here. We update our server, everything's fine. We don't use symbols, we want to use years. And then we don't have any parameters still, so we say try it now, execute. And we have an access violation. Wonderful. Let's see what I did wrong. And obviously it's good that I left this in, right? Because now you can literally see how I try to find these things. I know what I did wrong. And the good thing is you can follow the thing from the source, right? So you have your service definition. Okay, that's right. Okay. You have the implementation. Okay, that's right. So let's look at the implementation. Oops, we forgot the implementation, right? So here we go into the implementation, uses, and then we do U stock service controller. That's the one we need. And then here for years, we can say var controller T stock service controller create, try finally, and then controller free. And then here we do controller dot years. And that returns TDT or years, so we can set result to that. Perfect. Not year, years. And with that, now it's being implemented. Okay, of course, this is still running. Gonna get rid of it. So we start it again. Then start. We go back to the browser. We don't have to refresh this. So we click execute. And there we go. All the values from the database are actually in the result type. So this is one service endpoint fully implemented. And what we did is we just added the years to a list, and that's how we return it. Right from the start, what we did, we defined the method in the interface. We changed it to HTTP GET. We added the implementation in the implementation. Then we use a controller class to get the data from the database. And what we do is we use our database manager that we implemented in the last part of the series to get the query. Then we put the SQL statement into the query. We open the query, we make sure to throw an error if there are no years or if there is no data inside of this query. And then we iterate all the different records and add them to the list. And the list is being returned by XData and also serialized as JSON automatically. Of course, we have to make sure that the query is being freed and also the connection is being freed as well. We also wrapped everything after we instantiated the result into an except block that basically makes sure that the result is freed and that we're not going to swallow up the exception. We re-raise it, whatever it is, so that we can take care, or XData, I should say, can take care of it. Perfect. So that's really the cycle that you have to adopt if you return information from the database that you need on your front end. The symbols are going to look exactly the same way, to be honest with you. The difference is that the data type of the symbols is a little bit more complex. Instead of just having a list of integer, we have a list of objects. So we start again with result, tdto symbols.create, and then here again, try except. We don't want except on E or anything. We just want to accept. And then we say result.free raise. That's the outer block. And then on the inside, again, we do var query. We create a new query. And that is in tdatabase manager.shared.get query. Not to get the query. And then here, another finally block where we tdatabase manager shared release query a query. You see, this is really boilerplate code at some point that you have to write in order to get your queries. And of course, you can even mush this up a little bit more. You can create query managers and all that kind of stuff that your actual service controller becomes smaller and smaller. You can outsource this in other units and make it more generic if you wanted to. So select equals, and then here, 3. That's the statement. And the statement is very, very simple. It is select distinct symbol from stocks, order by symbol. That's the SQL query that we have. And just like before, I'm not going to re-implement this all or type this all. We are going to open the query. And if we have reached the end of file, the EOF, there are no symbols. Otherwise, we iterate the whole database or table lquery.next. We iterate them all. And now we have a difference because now we actually want to fill a symbol. So we have L symbol of T symbol DTO or DTO symbol, sorry, TDTO symbol dot create. And then we have to fill all the different properties of that symbol. You can also create your own custom create a constructor here to pass the values. In this case, as it's only one, right? We only have the name. We can literally do here lquery.field by name. And what is the name? Well, here, select symbol. So that's the field name, symbol. And then as string. That's it. That's how we assign the value. And then, of course, we have to add it to the list, result, add L symbol. And that's it. That way we add the symbol to the list. And at the end, we will have all the symbols in our list. Perfect. And with that, believe it or not, we're done. We have the data that we need for the 2 combo boxes. Let's quit the service, start it up again. Okay, what did I forget? What did I mistype, so to speak? A query, oh, sorry, it's L query, of course, here, L query. And of course, even though it compiles, we have to remember to go to the implementation. And this is actually very, very quick. Again, we can copy, paste, and then L controller and up, we're going to do symbols. Because TDTO symbols, L crawler symbols, that's all we need. Linking and start. I'm back here, and now we can try the symbols, endpoint as well, try it out, execute. And they're all the symbols, but it's not just a list of strings, it's actually the name property of the class is being repeated inside of this array. We also get like an ID added by XData automatically. Just be careful, this ID is not unique or anything, it's only unique inside of this array. So if you have multiple arrays at the same result, this is nothing you can use in order to go back to the database server and say, okay, I want to update the database with this ID. This is just something that XData adds. I think by now there's even a property that you can set on the XData server to disable this behavior, that it's no longer being added. It is something that is used if you convert your database to an Aurelius model, or if you are working with an Aurelius model, then this ID is of particular importance, because then the automatism that is being used with the Aurelius framework can then decide which record has to be updated, deleted, or whatever you want to do with it. So that is important for other stuff, but not for the things that we do. So this is just added without any particular reason. Again, we have the value as the object property. So we always return an object with value as property. And then in this value, we have our array with the different list items, so to speak, in our list, which correspond to the records that we have in the database, or in our query, I should say, because the database has way more records, but this is like the query result with the three tuples in there. Okay, that's already a big step ahead. Obviously, it's still all very, very cryptic, but now you kind of get a feeling for how this works. So the next thing we need to do is return the actual data. So we have something more palpable for you, how you return data from a web service. And yeah, we actually not only going to return the data, we're actually going to return the whole appearance of the chart. We're going to look at the chart.js documentation first, and then we're going to return the appearance plus the data for our stock. And then we can already, believe it or not, start building the web design and look into how we can retrieve the data from a web application. As said, as a use case that XData is universal and cannot be only used with TMS Web Core, we're going to use that or do that with vanilla JavaScript first. If you don't know JavaScript, just ignore what I write in that code. Just enjoy the fact that we build with HTML and Bootstrap, we will build the user interface, ignore the JavaScript, and then concentrate on what I do, because I copy paste the design into the TMS Web Core application and can then create the whole application in TMS Web Core using Object Pascal, and even the chart.js framework will only be like about 4 lines of code that are a little bit cryptic, so to speak, because we need to make calls to JavaScript directly, because obviously there is no chart.js control from TMS. So we call the JavaScript class directly from TMS Web Core. That is possible. You can call JavaScript code directly, but we're going to create a separate class for that as if it were a component. So it will be all very, very nicely arranged code and easy to manage, and hopefully also easy to understand. So let's take another break, and I'll see you back in the next part. Bye-bye.